Okay, this is crazy, but I'm going to try it, of course. So I got, this is the 1/2 inch bar that I want to bridge between the headlights, the headlight posts on here. I quandared over 1/2 inch bar versus 1/2 inch tube. I opted for bar, okay? I opted for bar. Again, drew my line at the top. Stop point is the same on each side. Stop point lands on the center of the arbor. And what I did was I took a piece of pipe that fit on there tight, 3/4. It's a 3/4 pin on the jack. Just blew out this shape and did some slits in it so it bent evenly on both sides. Blew it out on the plasma. Sized it to a couple of I think they're lawnmower bearings, not for front wheel bearings or something. Excuse me, 5/8 shaft. Took a piece of 3/4 inch shaft and put a piece of tubing in the center for one of my my 1/2 inch bead roller dolly or die. Built it up with weld and then turned the whole shit mess in the lathe. So this bearing, you can see this bearing goes out that way. This bearing goes out that way. So if I pull that bearing out, I can pull the shaft out, which allows me to take the die out and pull that bearing out. So I'm going to try to get a 3" at the peak. I just need 3 inches of arc. I'm going to try. And this one, I'll get the tripod out and have you guys watch. Okay, I have not tested this. I have one piece of bar. I just picked it up at St. Big Money. And I can get more. I mean, it's $5. So now, I got the drill on low. Okay, I think it's going to work. Okay. Let's try one pump. All the way up. That did nothing. Okay, there we go. Come on, little gal. Maybe I just need to put a crank on it. Maybe I need to relieve it a little bit. Come on. Come on. My chuck is so bad on here from tapping. Okay. I think I failed, and I think I know why. Get a little Rue Glide on here. These rollers weren't spinning freely, so we're gonna attempt that now. Pressure is higher than one thinks on the bar. It's got to overcome that. So get rid of the friction is probably important. Yeah. Yeah, that ain't gonna work. Yeah, it isn't gonna work. There's just too much force on there. Fail. Okay, that was a fail. So I went in back. And made this handle. Just welded it to it because everything comes out that way. I just have to make a minor modification. Just bear with me. This is a prototype. Just a minor adjustment. Proof of concept, you know. Okay, so everything's there. Got a line. Get a jack. Tight. Slide this off so I don't bust any knuckles on this experiment. And we'll try it again. You you can steer a little bit with this thing, which is probably scary. Okay, let's see what happens. Certainly control. Wow. Yeah, I gotta freeze the steering part of it. It's kind of interesting. If I steer just a little bit, I can roll that pipe. Turn the line. I got my line trying to keep it on top, on center. There we go. And we're there. All be dipped. Oh, that's not my word. One more point. God, that is so cool. But it should just be a straight. I can put a little bracket on here. Would you look at that? Wow. Wow. I want 3 inches. I might have it. I might have it. No, I don't think I do. Where am I at here? Nice and flat. 1 3/4. A little better than halfway there. That is cool. So I just got to stabilize this. Maybe make it adjustable a little bit so I can fine tune it. Make sure I grease these every time I want to roll a tube and go from there. Okay, so I got the curved bar. And he is going to set in there. I'm just going to set it on the fenders just for the sake of, I'm just going to find a gap there and a gap there. Okay, you know, they're not the same, but they're close enough right now. So I want to trim each of the sides at the same distance because I have a consistent curve, right? And they're going to mount to this. But I don't want to weld it to that. I don't want to fix it to it. I want it to be able to be removable so you can remove one headlight or the other, you know, serviceability type stuff. So I come up with an idea. Took some 3/4 inch bar stock. Again, we're back to the old, I don't know, lawnmower axle, something like that. Anyway, and I chucked it up in the lathe. Okay. I turned a little bit of a taper on it so that out here you got about 3/16, 1/8, no, more than a 1/16 in less than an eighth, more than 1/16, and so whatever, 3/32 thickness on here. So I just ran that taper. All I did was say, hey, if I'm 1.5 inches long, and I want to taper from 3/32 to 3/4, what's my angle? And it's approximately 5 degrees. So I just set the stock up at a 5-degree cut, and then I cut 5 degrees on it. Then I chucked it up in the mill, zeroed it in, clocked it, plunged for 1032 socket head. So I drove down in a 3/8 because on a 1024 the head is 313 on a cap or a socket head screw, one with an Allen wrench. The thread diameter is 0.19, and I went to 200 on these holes, and it's a 190 head depth. Well, I can't get enough depth, without sacrificing the material, so I kept that thickness, and then I just plunged with the 3/8 end mill, so that there you go. Get in a light. I would have, there you go, plenty of thickness on the inside of the hole, right? So then the dilemma is, how am I going to get this horizontal cut exactly in half, in the 1/2 of the now tapered tube that I still need to cut off? And I came up with a plan that I would try. And of course, that's at the end. I'm trying to look for there it is. So I grabbed a roll lock disc because I knew they unscrewed. Grabbed one of these 3-inch die grinders. They're 75 thou thick, or this particular one's 75 thou thick. The hole is like 3/8, and this shaft is 1/4. So I eyeball centered it up. It happens when you eyeball center it up, right? It touches on one spot and then not the other. But it's a grinding disc. So I got that good tight. I dialed down to the top of the shaft. Okay. Zeroed out my Z. And then went down subtracted half the distance off of here, half the thickness of this, 75 thou. Plunged down to the center line. So the center of this is on the center line. Turned on the mill and just moved along the x-axis until it penetrated. Went around the other side, did the same thing, and it actually worked extremely well. Then I got 2 75 thousandths cuts. So I got 2 equal halves, as good as they could be with the tools that I have. But I mean, So what's going to happen now is I need to identify the angle of the cut on that tube. So that I can weld it onto this. And so that'll stick out about 1.5 inches. It's 1.7 is the total depth, but it's gonna be on at an angle. So about 1.5 out. It's gonna stick out and at that angle. And it's only gonna be the back half. So the screws will come in from the back. So I will get that positioned on there. That's the best way that I can identify with a specific position. I mean, I can measure down and I can get a location, find the center on here, right, and all that. So what I'll do is I'll probably block this up to the location that I want it, get it centered, identify on each side that angle. Then I'll run over, use my angle finder. The triangle thing that gives you the varying angles. angle gauge. I'll identify the angle. I'll translate it to that. I'll have my dead end on here. The tubes will go all the way down. Run my holes through and tap this. Bolt it on. And then proceed in just trimming and finessing till I get it in and then tack it. So one half will be on the back side there. The other half will be on the back side there. The front half of that half circle will be part of the 3D print, right? And I'll have these two pieces connect, but they will be able to come apart, whether they snap fit or a set screw or something that holds them together. For the covers, it'll be a factory look, but it'll be something where you can take the front half off to remove that bar on each one of them. So we'll be able to disassemble. It'll certainly secure that 1/2-inch bar, and it'll be the other half. I'll just copy the taper onto the 3D print so that everything will look like it's supposed to. So at this point, get those pieces on. Okay, cut those pieces off. Okay, by basically laying this up, laying this assembly, getting that angle. I'm welding these on, so I mean, it doesn't have to be mission critical. But laid that up to there, translated that mark to that, and then flip it over. And we'll, doesn't matter which side I put it on. In our heads, we say, well, we're looking at the front. This is the back. So this will be on, excuse me, this will be on the driver's side. That'll be on the passenger side. So now I'll rig this. It's a 1/2-inch bar. I get a couple of pieces of 1/4-inch, clamp this whole thing down. I wish I had a mag drill, but I don't have a mag drill so that I could go dead straight. So I'll have to figure out a way to rig it to get a nice straight hole. I got the drill press or the mill, but I suppose I can grab on the tail somewhere. The key is, of course, to get this totally horizontal, right? Totally horizontal and down. But again, it's not mission critical. I need to get a couple of number 10s in. I think this and this need to be identical. I can, again, clamp with 1/4-inch stubs on each side and then clamp the whole works down. Certainly do a transfer punch, you know, to get a hole or to get a mark in it. Get it flat in the mill. The nice thing is that roll, you can see a little light there, but you know, is my bench totally flat? And anyway, that you know, 3 thousandths isn't going to matter anyway. So, and then I'll cut off. I'll get my holes, waz off, you know, stay back a little bit, allow this thing to weld on, and bolt her up and see how she looks. Alrighty then, we've got these two mounted, and I took the liberty to just run a 3/8 channel, flat surface area, across the center line of this bow so that I can put a 1032. In this case, this is a 1/4-inch, but you know, if I make a sheet metal type emblem, a lot of the old Chryslers from the 30s had like this would say 66 if it was a series 66 and that kind of thing. Now again, this is the back, right? This edge is the back, this is the front. So those holes were blind. These are 3/4 inch screws, so you just come to the surface, or 5/8, pardon me, 5/8. And now the task will be to, let's see here, weld that in there, weld that in there, just those halves, so they bolt on from the back, and it'll give me that bar. Should be fun. Almost there. Well, coming around. He's got the hood side on there. They're big. They're precisely what I wanted. There's the front end. Got those pieces all welded on and cleaned up. Disassembled everything, tigged those together, and then cleaned them up. I'm probably gonna wind up powder coating these because they'll be underneath the cover. So now the cover will come up. It'll transition to, because this is this way, this type of a piece is that direction up here, right? So how these transition up, I don't know. That's all in the modeling. And then the front of this piece of plastic that goes on here will be the other half of this little handle. So it looks like this piece fits into there. Wiring comes up through from the bottom up through under the fenders up through, so there's no exposed wiring or no loom that's exposed. I did order the headlights. I may have mentioned that. Halos, that's the term. They'll have halos. They'll have the blinking function, high and low beam, and a few other features on them. So I don't plan on mounting signal lights on it today, at this time. The crossbar will complement the grill just perfectly. And I'm very, very, very happy with the results. So this project is complete. I will clean up the garage. It's a Sunday for me. I'm going to go visit my mother and then change the oil on my truck. Thanks for watching. Much appreciated. Well, I've been working on the taillights now. I got 2 of these. And they're rough, but remember, these are going to be painted. They're rough in the sense of the chrome. I could probably polish them, but I'm not going to go chrome. You can see a little bit of work right there. But I polished the lenses. They got fingerprints all over them, and that worked out well. And what I did was I made an LED array. Okay. So this array up here is all 5 volt. These 3 down here are 5 volt, and the center band is 12 volt. And it'll sit on here like this. And I may even put a piece of ABS in here to block it. But my initial tests, it all depends on how deep this goes into that housing. But my initial tests indicate that it works really good. These light up, and then stop gets really bright when you hit the brake. So they're wired. I'm just waiting for, you can see the bottom 3 LEDs don't have the retainers, the barrels, so I have to get those yet. Anyway, so working on that, and I started with grafting out my skeleton for the taillights. The fenders come down on the rear at a 45-degree angle. This railroad tie is cut at 90 degrees. My 45 is off of my fender. Okay, this simulates the fender mounting. So again, back to a piece of pipe. Just TIG welded onto a flange that I just cut on the plasma table at 90. The flange will mount on the fender at 45. And right now I am working on the rear. Where is that other housing mount? Carefully cutting back on on this piece until this piece had ears and everything else on it, but I cut all that stuff off, and now I'm just tracing and carefully cutting to get one, and then I'll copy that same profile on here. I cut these at 45, but you can see it's not exactly 45 when you get it all set up at 90. So now I'm just trimming until I get it a perfect fit. Then I'll make an alignment jig, which in this case, the sides of these holes will line up with this. This will stay on this line. This is 90 degrees to this line. And then I just kept the fine center on this and this. And then I'll tack them on. So she is coming. Well, there's the other one right there. So that's the project. Now I'm still wondering what I'm going to do, if I'm going to cover it. I don't like that straight look, so we're working on it. So we got some stuff going on here now. Paper pattern. I wrap paper around the post and around the shoe. Okay. Took some 18 gauge and cut out a profile. So now I'm just slowly wrapping it around the shoe. I mean, I started it on this line right here. It doesn't matter that the line's not dead on the corner. What matters is that I started forming right there. Now you can see she gets a little bit tighter here. This one I haven't done a whole heck of a lot of work on. Just got it started. And the key is to just keep that area flat. See, you got a curve on that area. And as I start to do that tapping, I'm going to go back and reference my line. So in this case, I have some tapping to do in this area, which is going to push that material up, push this down. And I have some tapping to do a little bit right here, it looks like, as well. So I'll just start to form that. And eventually, this guy's still hot. I might have to come back. She'll start to take shape. So that's that, whatever, 7/8 OD, some metric tubing, it didn't really matter. And that's the bottom. And I'm slowly, you can see I got a little bit of tapping to do right in here. But of course, as you weld, well, that's the end of the bead right there. Here, I'll go parallel to the bead. Okay. I'm just going to keep on going. And yes, I get a little extra material. I don't have these flat. I just finished welding it, and it is hot, but I'm just touching the edge. But I got a little bit of straightening to do, you can see, because I just finished bringing the weld over. In this case, I'm MIGging because I'm exposing there, you can see. See, I'm trying to expose that 10 gauge underneath as I'm working my way around. It's not following perfectly, but I'm exposing on the top and the bottom, so I want a lot of material going in a small amount of heat signature, you know, to just try to keep as much deformation out of it as I can. So now I'm wrapping them. That's the hot one. Anyway, they'll sit on the fender and get straightened out, but they'll sit on the fender and look like that. In this case, I'll have to finish these corners. You take them to finish, which I hate inside corners, but it can be done with a Dremel. It's just time consuming, but making progress. Okay, almost there on this one, and I finished wrapping this one. Okay, just slowly cutting, just bringing it over, running my cutoff wheel in. You know, the cutoff wheel's 40 thousandths thick, 40, 50 thousandths, less than a material thickness. And just keep on tapping and tapping and tapping and watching your line. But you can see just running across the top of my bead. That's going to finish out really nice. That's going to finish out really nice. So it'll sit in there. I got some work to do. She shrunk in a couple of spots. That actually looks fine. This little light line on the bottom, that doesn't bother me. If the other one looks exactly like it. Here's a little bit of wrinkle there. I'll have to do some tapping. That side just turned out really, really, really nice. Number 2 coming up. All right, I have them completed. That's the weld side. Just did them with 80 grit. So they'll sit on the fender like that. And I mocked one up here. And from behind then, I don't know what the TV does to these LEDs. It'd probably be flickering, but basically from directly behind you got that. And get a hint of stop and blinkers and that. I don't have the position perfect. I just set it in there, put some tape in there and some crushed paper. And the bottom LEDs will be straighter. They'll actually look like those. But I'm happy with it. I think that's going to be super cool. Hey folks, a couple of things here. So we have this. This is my prototype set mock-up, which I liked. You know, I didn't have everything perfectly centered, but I didn't like the 3 lights down there and the unevenness. I wanted more of a pattern. I polished this to a certain degree to see if I could get enough surface finish on aluminum. I just sanded that. I didn't polish that. And I like how this very bright LED works for the brake lights. So now we need to go on to the actual product. And so what I did is I determined a couple of things. Number 1 is what the array would look like. That's a center hole for mounting, and then basically a triangle up there and a triangle down there, leaving space for this board. And I think, you know, this, although, you know, with hot melt glue and stuff, it can go through a bunch of tests and that and work okay. It's not going to be robust. So I have some hobby printed circuit boards, and that's the smaller diameter in there is the printed circuit board. So I located a center line on the hole. You can see a hint of, it's not the actual center line, but it got me close to where I wanted to start looking at the holes in the board, right? I just measured both ways. Okay, then I drilled my center hole. I stacked the two together. I'm not going to rotate it, but anyway, look through the vias or the holes until everything lined up perfectly. These printed circuit boards this one was rectangular, and they have 632 holes, number 6 holes in each side. They're probably number 4, but a number 6 would go in and retain them, so I put one in each corner. It has it on all 4 corners. I put one in each corner. Excuse me. Drilled through and through, and it's just a 1/4 inch hole basically. And then I put a bolt and a couple of nuts on the back side. Chuck the nut side into the lathe so that it would, as I was cutting, it would only go in the tighten direction to retain it, and then cut that to specification. I made a little pattern here so that I could mark my circuit board. This is a dual pattern, obviously you can see that, but I mean, mark it with a Sharpie, take a grinder and cut most of the fiberglass away, and then chuck it up in the lathe. And then this one I did the same thing on aluminum and made 2 pieces of aluminum. Okay, and these will be the backers that will be polished. They will set neatly on a standoff right here in the tail light. Okay, and that standoff relies on this center bolt. They will all be the same. You know, they'll be button head Allens like this when it's all said and done. But so that will sit in there. I need to determine what to do for a location, and I need to get a method of screwing this, securing that down. So a tab to hold the tail light in, lens in. I got a whole bag of these 5mm LED barrels. So an LED just pushes in from the back, and then you just see the face of the LED on the front. Well, that's what these are. There. Here's a look at them. So in this case, what I will do, there's a grid that I set up on here. So these holes, these barrels, are 100 thousandths centers, 0.1 centers. So I built the grid. It's gone on here now. I just offset lines 100 thousandths in the X and Y direction and built this side, then mirrored it and then mirrored it down. But what that enabled me to do then is to locate all of the LEDs properly on the printed circuit board, so I can put them through and then carefully solder everything together and tie everything together. My research indicates that I can go to 4 3 volts. I can probably get to 3 volts, but with an alternator bumping the voltage up to 14 volts, I think I'd blow them. And I don't have any type of regulation at this. I might actually get the regulator, but conditioner, but I will take and do, this array has 1, 2, 3, 4, 5, 6, 12 LEDs in it, and then the brake lights, these are 12 volt LED. This is a 12 volt circuit right there. So with 12 I can tie 4 or 3 together. They're 20, it doesn't matter. They're 3 volt LEDs, so more than likely I'll have to take 4, 1, 2, 3, 4, 1, 2, 3, 4, and tie them together with a resistor. And so I'll pop those into the appropriate locations. I'll run them in a serial connection, 3, 6, 9, 12 volts in a serial connection. And I may, or if I go parallel, then I would need a resistor. I'm going to play with it. I bought a bag of 100. And I use a battery charger because a battery charger on 6 amps is about 13 volts. I can go a battery charger on 40 amps and get very close to like 13.7, 13.8. But I just don't want to blow them, and if I blow them, maybe I'll do that just for the test, and if I blow them, then I'll have to connect another LED in the circuit, in the string. I'd really like to try 3, but in any event, I won't ramble anymore. So they will be soldered into here. This will be carefully placed onto here. It stands off. I don't know what the dimension is. I haven't measured it. Approximately 1/8 of an inch. The LED will be on that flat surface. They'll be buried down to the surface. This will go onto here. I'll measure and put a shim between the board and this. This will be a chamfered hole so that I can put a screw through that spacer, through that PCB, and tighten it onto this long nut. I may have to make that to get that distance perfect, but if not, I can chuck this up and narrow it. If it needs to be longer, I'll just make one or buy a longer one and chuck it up. In any event, that'll go in there. Then the lens will go on. Now at this point, it's kind of there. You can kind of see now how the LEDs line up. So then polish all of this before I set it on, before it's all complete. Polish it, assemble it, and get it on the car. One thing I didn't consider is on the length of these relative to the fender is if I could fit a license plate underneath it. It appears I cannot, which kind of sucks. However, I can deal with it. The license plate can go in a different location. So that's what I'm working on, and I'm having fun doing it. Well, I just got in my new sandblaster. I've been borrowing from my brother. Came from China. It's made in China. Took a month to get here. But it's a 2-bag unit, and it's, wow, who cares? But I searched for one like this. Not with that flapper handle with the rubber thing that goes over it, but the actual ball valve is right up here at the hose rather than down there. On the ones that I've typically used, you got to reach down there to turn the sand on, turn the sand flow on, and then you got this flapper valve up here that shuts it off. This will just shut it off strong. The other thing is the flapper valve. This one had that ball valve down there, but I made a bracket with the bell crank up to a lever up here. Now, and I got pressure in there. Now I can adjust my sand flow right in the same area everything else is adjusted. All 3 knobs are at the same spot. Anyway, and I just ran all the air out. Almost. Yeah. Can't wait to use it.
really do not want to mess this up. And the reason I don't want to mess it up, because I'm welding on the inside of the roof. I'm not interested in cutting it all back off. I want to take my time and try to do a good job. I'm going to go with this.
Okay, you could see that I've got the arrays built, okay, so far. And I got a bag of these, I don't even know what they're called. I call them barrels. Bulb socket bezel holder. And then I got 100 of these super brights. I did open that hole up, and I got to run and get a chamfered head screw. And then of course then this goes in, and I think you saw that, but you know, those bulbs stick in each one of those sockets, and then they actually clip onto the base of the bulb, so that'll snap on. This will snap onto that. That of course will be retained in there. Now I sandblasted these and powder coated them, so I'm not going with chrome. Went over that before. And now I've got one assembly finished. So I got 4 circuits. I'm using these 3 bulbs. They're I think they're 20 milliamps. LEDs, 3 volt. Yeah, so 369. I need to bring my voltage down. They'll take up like to 3.3 volts, but you know, the battery's going to go to 14. So I'm throwing in a right there. A 220 ohm resistor, half watt. I could probably put 150 in, but they're very bright bulbs, and as compared to the last ones. And I want to let my battery charge to 14.7. You know, I don't want to blow the taillights. So I'm going with a 220 ohm resistor. And let's see, I polished these. They're full of fingerprints right now, but I didn't, you know, go bonkers on them. I just wanted that surface to be good. Chamfered that. And why are those chamfered to go into there? Why do I need to get those screws? Because the brake light array, which is already built, I'm taking off of this. And again, these are extremely bright surface mount LEDs, and I think that combination is going to work just perfect. So that's what I'm going for. I'll keep plugging. Okay, so here we're looking at the prototype. You know, just a bunch of resistors put together and hot melt glue, keeping things from contacting each other as I monkey around with it. Okay, that was the prototype. So now this is the finished product. Still use the hot melt glue. Everything's soldered in to a printed circuit board. Okay, got my ground legs. I got 4 circuits in here, 3 LEDs in series. There's a total of 12, so there's 4 different circuits, each with a 220 ohm resistor in it. And then using this purchased bank for my brake lights. So I have the array above and below. On the stop, and since LEDs are so directional, I considered diffusing, but you have to have some distance, you know. And when I attempted this with the height of the lens, you could just see brown circles. You could see the LED outline. You had to get an inch, you know, inch and a half away before you'd have enough diffusion to give you a solid light. So I got another idea I'm going to use for that. But at this point I can show it to you. I'm going to turn on the charger. I assembled this one. So looking straight on, you will see that kind of a look, and then when you hit the brake or turn signal, Pretty cool. So it's all coming together and looking pretty good. Straight behind it, extremely bright. You get off to the side, you see the array on the lens. I'm probably about 80 degrees from the light now. Almost think a guy should probably do side markers, huh? But I think that turned out really good. I'm very happy with it. All right. I didn't wire them up, but I got them mounted on. They look pretty cool. Turned out really nice. So you wrap around. I kind of got them set just about flush with the back of the body. The plan is to have a spare tire right here with a cover on it. So it'll have a third brake light, reverse lights, and the rear backup camera will be on it. And then I'm just thinking about notching those out, getting an eyebrow in there probably to follow that profile of the fender and mirror it on both sides, and then doing cutouts coming out of there. Kind of tie this all together then. So just thoughts right now as I dream about it. So having fun. Another project, little mini project complete.